A very good day to Sir and my lovely classmate. Today I'm here to present an assignment for BTW3213 Pedm. We are being assigned to design a DC to DC converter. As an introduction, a DC to DC converter is an electronic circuit or electromechanical device that converts a source of DC from one voltage to another. Of course, it's also named as a chopper. A DC to DC converters are commonly used to provide a control and steady voltage from a fluctuating or a non-constant source to limit the switching noise and maintain regular DC voltage. These converters use high-frequency switching circuits such as MOSFET, including inductors and capacitors. So, typically, DC to DC converters consists of several key components, which is inductor, capacitors, resistor, transformer, and MOSFET. So, what's the working principle of the DC converters? It's actually very simple. The inductor in the input resistor has an unexpected variations in the input current. If the switch is kept as high or on, then the inductor feeds the energy from inputs and store the energy in the form of magnetic energy. If the switch is kept as low or off, it discharges the energy. That's all from me. Thank you.
Okay, Assalamualaikum. My name is IMRAN bin ROZLI SHAM and my student ID is TF19016. Okay, today I would like to present about what is the buck boost converter for our assignment. Okay, buck boost converter is a type of DC-DC converter that has a output voltage magnitude that is either greater than or less than the input voltage magnitude. And a buck boost we know that a buck is for the step down converter, and this buck boost converter that we have combined two converter in one. That boost is for the step up converter and buck is for the step down converter. And next is the circuit operation depend on the condition state of the MOSFET, which is on state or an off state. Okay, for the next slide, I will present the advantage of buck boost converters and the disadvantage of buck boost converters. For the advantage buck boost converter, first point, we get the buck boost converter offer most most efficient solution with a smallest internal components. And next is a perform step up or step down of voltage using minimum components. And third point is offer lower operating duty cycle, and it's also offer high efficiency across wide input and output voltage range. And last point for advantage buck boost converter, it is a less expensive compared to others converters. Next we go to the disadvantage of buck boost converters. For the disadvantage, we have the input current and charging current of our output capacitor is discontinuous, as it result in large filter size and more EMI issue. And next disadvantage is output is invert, which result in complete sensing and feedback circuit. As a sense voltage is negative, inverting op-amp is needed for feedback and closed loop control. And our 4 point for this advantage of buck boost converter is there is no isolation from input side to the output side, which is very critical for many application. And lastly, for the disadvantage of buck boost converter is transfer function of the converters contain a right half plane as a zero with introduced control complexity. Hence, it's very difficult to control such a converter type. Okay, we go to our next slide. Okay, this is the calculation that we have made in the report, the calculation of the component. We know that our lecturer give different V out V out punya nilai, or we can see we have a voltage supply 32 volt. Our V out we have 300 volt. Our power out we have 450 watt. Our resistance that given is 10 ohm. Our voltage ripple 1%, and our I out is equal to 1.5 ampere. For the first step, for this calculation, we must to find the switching frequency FSW. We get 20 kilohertz. And next step, we must to find the our duty cycle for our circuit. We get 0.89. And our third step is to find the value of inductor LMIF. That we can see the formula, and we get the result of 50 microhenry. And we get we must find the actual inductor is 25% plus with the inductor result or inductor value. We plus both two, and we get 62.5 micro. And next we must find the capacitor value. We get 22.3 microhenry, and lastly we have to find our resistor value, and we get about 200 ohm. Okay, that's all from me. Ali Imran bin ROZLI SHAM, and my ID is TF1016. Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amierul bin ROSME, and I continue to DC to DC converter in photovoltaic system. Let me see. As we see on my screen, I show based on the diagram, we can see PV panel is a device that can convert sunlight into electrical energy. So the voltage current passes from the PV panel directly to the DC to DC. And why the PV panel current also passes directly to the MPPT and make one patch and directly to the DC to DC. Okay, the DC or DC converter is provided to regulate the constant output voltage under various operating conditions of photovoltaic cell. A maximum power point MPPT is used for extracting the maximum power from the solar panel and transferring maximum power from the PV module to the load. A DC to DC converter which interface between load and module serve the purpose of transferring maximum power from PV module to the load. Okay, next for the conclusion, a DC to DC converter is introduced between PV system and load to meet the dynamic energy requirement of the load in the efficient way. It is observed that the DC to DC converter largely increase the system efficiency by using MPPT technique. Okay, for the discussion, the DC to DC converter that has an output voltage magnitude that is either greater than or less than the input voltage magnitude. It is equivalent to a flyback converter using a single inductor instead of a transformer. According to theory calculation, it is possible to meet the voltage regulation with the given calculation, but this will only happen with the converter is an ideal condition, which is not heat loss 100% efficiency. As we conducting the MATLAB simulation with the calculate component value, the value dropped into half of the estimate theoretical value. For the lastly, but we can conclude that the circuit is working according to its working principle, as the value of volt V out 150 watt is largely boosted from V in, which is 32 watt. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and a very good evening to my teammates and also to our respectable lecturer. My name is Muhammad NAZIRULNAIM bin SHAHIDAN, TF19017, and I would like to present to all of you the tutorial about the buck boost DC converter. And as you can see on my screen is that I'm using the MATLAB software to represent our simulation. So the difference between the buck boost and also the buck boost converter is the emplacement of the MOSFET, the inductor, and also the polarity of the diode. The rest are most basically the same. And we calculate the value of component. So we set the value of inductor, which is around 195.31 exponential -6, which is represent microsine. And meanwhile, for the capacitor, we set around 4.8 exponential -6, which is at 4.8 microfarad. And for the resistor, we set around 625 ohms. Considering we have the input voltage at 32 volt, we need to achieve a regulated output voltage at 300 volt. And let's make a run on the simulation. As you can see on my screen on the graph, it shows that the output voltage fluctuates from 0 volt to around 150, or most basically we can achieve around 167 volts. Let me zoom it. Yes, the value of the output voltage fluctuate around, we obtain the value around 167 volt. And as you can see at the edge of the graph, the polarity of the output voltage is negative, which is exactly according to the theory principle. And this shows that the DC converter is proven to increase the value of the input voltage from a lower value into a higher value at a constant rate. This marks the end of our tutorial for the buck boost DC converter. And Muhammad NAZIRULNAIM bin SHAHIDAN signing off.